Good morning, children. I welcome you all to this session of science. We are on to chemistry and we are on chapter carbon and its compound. Right? In my previous session, we have seen why carbon is a special element and little bit about bonds, what are covalent bonds and how are they different with from electrovalent bonds. Right? Now we should study about what is the versatile nature of carbon, why it is a wonder element. Now, first of all, it has a capability of forming multiple bonds. Right, it has a capability of forming multiple bonds. That is because of its small size and presence of four valence electron. This is the reason, right? Okay, so it has a small size and there are four valence electrons due to which it can form multiple bonds. Now there is another property which is very important, catenation. It is the property to link and form very long chain, right? It's called catenation, the property of atoms of an element to link with one another by stable covalent and form very long chain is called catenation, right? Okay. Next is isomerism. Isomerism is when an element have the same molecular formula but different structural or chemical structure formulas, right? You can see here in this butane is there. You can write it as C4H10, right? Butane, and you can see that it has an isomeric structure which is also there, right? See, this is also butane and this is also butane. In both of them, the formula is C4H10, but the structure is different. See, in this straight chain here, there are only 3 carbon, but here there are 4 carbons in the straight chain. See this one, right? So this is called isomerism, and this is first one is normal butane and the next one is isobutane. Now a note is there, catenation and tetravalency two main characteristic feature put together give rise to a large number of compounds, right? Okay, next we move to saturated and unsaturated. Now saturated refers to when all the valencies of carbon are fulfilled. All the valencies of carbon are fulfilled. See children, there is a small error here. Here also there is one hydrogen, right? Okay, so when all the valencies of carbon are full, as you can see in this figure here, that one electron of carbon is linked with the other one electron of the other carbon, and the rest three are linked with hydrogen. So that means all the valencies of carbon are fulfilled, right? But there can be cases that in all these three cases here, the valencies of atoms are satisfied with single bond, right? Whenever the valencies are satisfied with single bond, then it is called a saturated compound, right? Such compounds are called a saturated compound. But when this some valencies are fulfilled by double or triple bond, then it is called unsaturated. And saturated compounds are very reactive, right? Okay, now see, these are the formulas of saturated compounds which are called alkanes. What are they called? Alkanes. I am writing its spelling. They are called ALKANES and their formula is CnH2n plus 2. This is their chemical formula. Methane, ethane, see, 1 carbon 4 hydrogen is methane, 2 carbon 6 hydrogen ethane, 3 carbon 8 hydrogen is propane, and 4 carbon 10 hydrogen is butane, and C5H12 is pentane, then hexane C6H14, right? Then there is ethene. See children, in ethene there is a double bond between 2 carbon atoms, right? So double bond, that means there is unsatisfaction here. So this comes as an unsaturated. And then there is ethyne. See, there is a triple bond in between. And such compounds having double or triple bond are called the unsaturated compounds, right? They are the unsaturated compounds. Now see, there are chains. See, one is straight chain, the other is side chain. In these two diagrams, see children, this is a straight chain, and here there are the examples of side chain. Okay, these are the examples of side chain. Now in side chain, children, what you need to know is one carbon. See, from here to here, this can be a treated as a straight line, and this carbon will be on the side chain. Right, this carbon will be on the side chain. Okay. Now, this is an example of a cyclic compound. See, the bond is occurring in a cyclic form at between one. You can see here how we find it. See, this is 1, if we take it as 2, if we take this as 3, 4, 5 and 6. So at 1, 3 and 5 position you are finding single bond, and at 2, 4 and 6 position you are finding double bond, right? This is called cyclic, and this is benzene, right? This is benzene. Next, let us move into the group of hydrocarbons. Right, hydrocarbons, simply they contain hydrogen and carbon. There are three types: alkane, alkene and alkyne. Alkanes are saturated, they're having only single bond, whereas unsaturated are alkenes with double bond and alkyne with triple bond. Now there are some heteroatoms also, which are called functional groups, and they are Cl, and they are called as haloform, like chloro, bromo. Then oxygen, there are alcohol, aldehyde, ketone and carboxylic acid. See children, and alcohol is represented as OH, right? Aldehyde as CHO. You can write it as CHO also. Then ketone, CO, and carboxylic acid, COH. Now going by reactivity, carboxylic acid is the strongest. It is the strongest, right? And it will be acting as a functional group. Like if the salt is written as CH3COOH. Now how many carbon are there? 1 and 2. 2 carbon means ethane, right? 2 carbon means ethane, but this is an oic acid group here, so the name will be ethanoic acid. Name will be ethanoic acid, and their common name is called acetic acid, right? The common name is called acetic acid. Next is homologous series, right? Organic compounds having same functional group can be arranged in a series known as homologous series. The various members of such series are known as homologues, right? This is very, very important for you to learn, that organic compounds having same functional group can be arranged in a series known as homologous series. The various members of such series are known as homologues. Okay, so now see, these are homologues, right? CH4, in amongst the hydrocarbon series, CH4, C2H6, C3H8, C4H10. Then alcohol series, COH is there in all the four, but then the previous atoms number. See, what you need to learn is the difference is of CH2. In molecular formula, the difference will be of CH2, and in terms of atomic weight, the difference will be of 14, because carbon is 12 and hydrogen is 2, right? See, let me tell you how to calculate this in atomic weight. Carbon 12 plus 2 into 1, so it becomes 12 plus 2, which is 14, right? So that has to be the difference, right? Okay, and all the members of the homologues can be prepared with the same general formula, right? So I stop here, and I hope you enjoyed it as much as I did in making it. Until we meet again, it's a goodbye.